Okay, there you go.
Continue. Oh, cool. You can't edit that out. Oh, no, it doesn't really matter. Oh, it's telling me to leave the meeting. No, that's fine. Oh, cool. Hi, everyone. Welcome to my Docker Basics training, or not training, but talk. Hopefully this will be like a series of Docker talks that kind of will add, I guess, more complicated stuff as we go along. So it might be like an intermediate, maybe advanced, but I guess I'll call them for the specific topic we need to go on. So yeah, this is like Docker Basics, an introduction to kind of Docker and how it kind of fits in. Cool. So what is Docker? Everyone keeps saying the word Docker. What is it? Well, it's a container tooling kit. So it gives you a way to build containers, run containers, and orchestrate your container. The software is available called Docker Desktop, which is available for Windows and Mac OS. Those two are kind of like, because Docker is kind of based on Linux, with the Windows and Mac OS kind of run a VM to kind of manipulate, to kind of virtualize the Linux system. But I know Windows is coming out with the Windows Linux subsystem, which basically hopefully make it run native on that. But yeah, it's an open source tech. So if you want to look at the Docker stuff, I think it's under the code name, well, not code name, but under the name of Moby. So Moby's kind of like the open source version. Docker's kind of like the, I guess, the selling name of it. So pretty much, like I said, the word container. Everyone's like, what is a container? Well, a container is a standard unit of software. So pretty much the idea of a container basically gives you the way of packaging up your code and dependencies. So I guess back in the day, like when you used to release software, you basically have your, I guess, libraries that are required. So for the .NET world, we've got .NET Framework, and when you deploy your app, your machine that you want to deploy it to has to have the same version that matches it. So it's kind of like a coupling of the two. So, but generally, you could have problems where the version on your, I guess, your machine that you're launching on isn't the same as what your application is built against, and you tend to have problems with that. I guess with that, we basically abstract it from the environment, so we don't have to tie it with the deployment we're going. So for the DevOps guys, we can just basically build the container and give it to them, and then as long as they got Docker running on the machine, they just run it and it should work fine. You can easily basically take that software that you've built in that container and move it to different environments, and there should be pretty much, it should just work. There shouldn't be like a problem with it running. Like the only thing that could be changed depending on environment variables that you might be setting against the container. Sometimes people can face containers as kind of like a lightweight VM. So they're kind of like, whether they're kind of like VMs is that you can kind of have the apps isolated from each other. So I guess that's the reason we have VMs, is to kind of not have the apps kind of like on the same thing and kind of next to each other. But the thing is, the way it's different to VMs is where VMs kind of like have a kind of like a guest OS, so you kind of run it. So containers are kind of more efficient that way, where you don't have to have an operating system tied to it when releasing. And because it's not using a guest operating system, this kind of it makes it a bit more efficient, so you don't have to have two things running, and it doesn't slow the VM down, or the machine that's running the VM. Whoops, sorry. So look, yeah, so because it doesn't have an OS, you don't have to wait for it to boot up. Containers start instantly. But the thing is with containers, it kind of uses the host kernel to kind of basically talk to some of the lower level hardware. So pretty much as I kind of explained before, like we kind of go through this deployment transition. So as I explained, like in the old traditional deployment, we basically had one single server we deployed our application onto, and then like afterwards, basically I think for kind of like individual kind of release, it kind of like is difficult because you've released all your applications on one server. One server could go rogue, or one application could go rogue, and then basically potentially take on the server. So we kind of moved to like a virtualized system afterwards. With that, we basically could virtualize a machine on the single hardware, and if one application does go rogue, it potentially won't take down the whole system, it'll just take down one virtual machine. But the thing is with this, it kind of made it a bit more complicated still, because as I said before, virtual machines kind of just like a single machine where you have to make sure that your libraries are matching the application. And also, like I said, it adds the extra overhead on top of the machine, because you're kind of running an extra operating system on top per virtual machine. So basically now we're kind of moving towards the container deployment era now. Like we've had applications in our, I guess, company where we're using it. I think EcoHub was probably the first one. So with the container runs, with the container deployment, we have like a single server where we basically, as long as it has Docker on it, we basically can just run our containers, and we don't have to worry about having, I guess, make sure what libraries are stored for the device or server. Sorry. But as I said, like I guess people, like I said, the advantage of basically having container doesn't have much overhead. But like as we're transitioning to, I guess, cloud, that's kind of not the case anymore, because in the cloud they pretty much use VMs anyway. So I guess for us it's a lot better for the developers, so we don't have to worry about having to have the right versions on the server, and kind of decouples it from the DevOps team from us, so we basically know that software is working. So there's quite a few Docker lingo that kind of goes around. So people will say, oh, there's an image. So for Docker, image basically is the basis of a Docker container. So this is kind of like the package that you've built up. Container, pretty much this is kind of like the image that is running. Engine, so this is basically the software that runs the container. This potentially includes networking and volumes, and a registry. And the registry is basically where your images are stored. So the popular one for Docker is known as Docker Hub. Think of it as kind of like a GitHub registry where basically you push your images to, and anyone can pull off it. So pretty much like one of the big things of Docker is building your image. So the first thing you do is when you build your image is you have a Docker file. So a Docker file is pretty much an instruction where Docker uses to build up the image. So when you create your Docker file, you run the following command. So docker build -t, and then you have your arguments of your organization / your application name and your version. So the -t kind of like option kind of means tagging. So when you by default build your Docker image, it basically doesn't give it a name. So what it'll do is give it like a hash. So it'll be like a random generated number. So to kind of make it easy for you guys to kind of recognize the image you just built, use -t to kind of just kind of specify the naming of the image. So the way how the naming convention kind of works in Docker is you basically go by the organization. So the organization is normally like the registry kind of name, then /, and then the application name and the colon of your version. When you use version, I think in a lot of the original days of when Docker started up, a lot of people start using the latest tag. I think that this is probably a general consensus. Don't use the latest tag when you kind of build your images, because there's certainly some weird caching issues that can happen with it. So my advice, if you ever do build, probably avoid using latest. One of the things you can do as well, you can chain the tagging option as well. So you can basically do that many times. So if you want to do like multiple different versions, or even basically create like an aliasing name, you can probably you can append it on that, so just generate the same name for that container or image, sorry. And then afterwards you'd use Docker push the name of your image, and I'll push it over to Docker Hub. So this way you can probably, it'll be ready for, I guess, the server to pull down and run it. And I guess if it's like a service that potentially people might want to use, they can pull that from their machine. So pretty much I talked about saying there's a Docker file, and basically it's an instruction. So this is kind of like the lowdown of how like a Docker file kind of works. So when you kind of write your Docker file, you start off with a base image. So in this example, I'm kind of building a node service Docker file. So the first thing I'll probably do when I create a Docker file is I have the from keyword. So the from keyword is kind of like your base image that you're starting from. So every Docker file has a base image. So with what I'm doing with my node one, I'm using the node image, and I'm using the version 12 and the Alpine version. So most of the time when you use like your Docker file, I think a lot of people use Ubuntu as kind of like their base image. Alpine is kind of like another Linux distro, but a bit lighter version. Depending, I guess, what package you kind of are building, you might want to use the Ubuntu one, because Alpine doesn't have all the necessary libraries that you can get. But as you use or as you generate your Docker file, you can potentially add any more by using the package manager. But there are some potentially compatibility issues if you don't use different Linux distros. The second part I put is a label. So when you create your Docker file, it's best to put some labels on there. So for example, in this instance, I've put the maintainer label as the tooling team. So people will know who's basically maintains this Docker file. And if there are potentially any problems, they can contact us to fix it. The way how the label stuff kind of works is a key value pair. So with the label keyword shown here, you can kind of chain it for any additional things. So you can put a version as a label if you want to. So for this instance, like I said, in mine, I've used the word maintainer and its tooling team. I could put another one afterwards. So like I said, version equals whatever number version you want. So you can continuously add the extra labels if you wanted to. It's great for extra metadata. The next part is, so basically the next part I would be doing is creating a directory. So I'll be using the run keyword command on this one. So this one basically runs any shell command possible. So in this part, I'll be saying I'm creating a directory, and basically the next one, I'll be setting the working directory, the directory that I created. So there's a working directory keyword you can use. The next part is I'll be copying over my package files. So not package file exactly, so the package.json. So when you're kind of moving files across into the container, use the keyword copy. Basically, this will copy that file over across into the container. So for the way that I'm basically copying my package files or over is, so the next part is I can basically run npm package install. So the reason why I want to do that first instead of copying the whole application is there's like a caching system in Docker. So the good thing about this is with this caching system, so think of it as each step. So for example, in this part, when I copy over my package and do my npm install, because if these potentially haven't changed, they will just use the existing one that's already there. So this would have reduced the build time of the Docker images over time. Okay, the next one is I'll then copy over my code files over across. One thing I do want to say is sometimes if you see examples where people are using the keyword add, advise not using add for copying files across. Add is kind of used for different things, but also does a copy. But in the next probably one, I'll probably explain what the add keywords like in another talk. But for now, if you do copy files, advise using just copy. So yeah, basically the next part, I basically copy my source code across. Then you've got the env keyword. This basically sets your environment variables for the container. So for this one, in my package, I've got like a port, which basically is the port I'm exposing on, and the environment for the node application. So I've set these to whatever port number and set it to production. Then for the container, I'm telling it to expose the 1337 port, which is what I'm going to be exposing my application on. And then finally, at the end of your Docker file, you basically put the CMD keyword, which is the default execution point. So if you have potentially more than one of these, this will only use the last one that's been selected. So if CMD did occur halfway through the file, that would get ignored, and then it would just only run the last one. I know there's quite a few .NET people here, so for .NET, it'll be a bit different because basically what you would do in .NET World is you build your, I guess your libraries, and then you then copy your libraries across. You can use the caching system in some sort of way, but the way to kind of do that is there's another kind of technique you can use called the multi-stage build. I kind of want to explain this one because it's a bit more complicated, but in probably the next one, I'll probably explain what multi-stage build is for. Okay, now we've kind of built our images. How would we run an image? So I guess on your local machine, you then use the command docker run with specifying some options and then the name of the Docker container or Docker image that you create. So with options, you've got -d. So -d option is basically, these are the options that you probably be using a lot more anyway. So -d is basically running the container attached. So if you basically didn't have a -d in your Docker run, this will basically just run it in your command line, and you won't be able to basically reuse your command line. And if you exit out of it, it will just kill the container completely. Dash P. So if you're running like a web service, you want to expose the container port to your local host. So the way you'll do it is you use Dash P. The host part is your machine, and then the next part is the container port. So if I wanted, for example, my machine, I want to expose to port 80, I'll do Dash P 80 on my machine, and then basically the port I'm going to expose in the container, 1337, example before. So just to expose it out. Also, another thing you probably might want to use is set the name of your container you're going to run. So if you don't specify a name, there's like a random kind of name system. So I guess for you, if you want to know what it is, best specify a name, otherwise you're going to be hunting down what container it is after you create. You've also got the -E one. So the way -E is any extra environment variables you want to set on your container. So the way you kind of use it is you -E, the environment variable equals the value. You can also use, I think with -E, I think it is, you can use an environment variable file if you want to, and basically have a file which then takes those values and puts into the container. Then the next one is there is a -V one where you, if you want to mount the volume from your machine to the container. So the way it works is maybe there's some files that the container saves. You probably want to kind of basically save on your local machine. You want to do -V, your host file location where you want those files to be saved, and then mapping to the file directory inside your container. Useful commands that you might want to use for everyday, I guess, kind of working in Docker. Docker container ls. If you use that, that will list all the containers that are running on your machine. Then if you want to remove any Docker containers, so like if you don't need it anymore, Docker container rm, the name of the container or the ID from looking at from container ls. With Docker container ls, I should have mentioned, you can actually use Docker ps, but I kind of prefer if I introduce you guys using the Docker container kind of theme, because it kind of looks more as kind of go to the next ones. So as I showed before, you've got Docker image ls. So kind of keeping the theme of that before, it kind of is a bit more easy to know what kind of part you're kind of searching for. So with ls being used in a lot of Linux systems to kind of list what directory you're in, it's kind of nice to kind of use this kind of like a pattern into finding what you kind of need. So kind of similar to removing container, we've also got Docker image remove, where you can remove the images on your machine. You've got Docker inspect, which basically shows you the information of the container. In this part, it also shows you the metadata that we kind of assigned to the container with the label keyword that we said earlier. And also the final one, which is quite useful, is the exec command. So this command is kind of, for me, I've used it a lot because like if you're running a container, if you want, for example, want to go inside the container and have a look, the way you kind of use is the docker exec command. So this execute any command line shell operation inside the container. So if you want to go into the container, use docker exec. -IT is kind of like the interactive terminal, or TTL, is it, typing? Then the container name and the application that you want to go to. So for example, in the one I said before, it'll be docker exec, the name, and then bash. So then that will bring up the bash for that container. So then I could execute any bash cells in there. I use that a lot because, like, for me, if I can see there's a network problem, I can go in there and potentially ping other containers inside that container. Or other things that you might want to use it for is, for example, if you're developing quite fast, I guess, prototyping, you want to try new technologies, without having to kind of install, I guess, SQL Server or maybe potentially Mongo or RabbitMQ, you can pull those images onto the machine, and to kind of interact with those kind of containers, you want to use the exec command. So if you're using want to use Mongo, you can probably use the exec command and use the Mongo shell for that by just typing Mongo for the application name. So to kind of interact with other kind of containers, it's kind of great for that. I guess that's kind of a quick basic rundown of Docker. If you want kind of more information, there's the Docker website. As I mentioned before, like Docker isn't kind of tend to use a lot for production, or is used for like production because you're kind of creating artifacts and being put out to servers, but it's also great for deving as well, because for me, it kind of basically removes the need for having to store loads of application on your machine to kind of bloat it up. So I guess a lot of people, when we kind of started off, we kind of had to install SQL Server on our machine, and having a look at the installation steps can be quite daunting. It's like, install this, install that, install this. We were just kind of using Docker. I can just pull that SQL image down, and then I've got SQL Server running on my machine without having to worry about it. So as a developer, it's great because I don't have to install loads of software and having to worry to manage it. I can just use a Docker image. If you even wanted to, you can pull down the Minecraft server if you want to run a Minecraft server, and then basically just remove it. It just makes things a lot simpler. But yeah, that's kind of the basic rundown of it anyway. But yeah, any questions, anything that kind of might passed over that you want extra information on?
I've got a couple of questions, Steve.
Yeah, sure.
You mentioned earlier that you push to Docker Hub.
Yeah.
I'm assuming there's one central repository that you call Docker Hub.
Yeah.
I mean, is there only ever one, or is that just cloud-based something?
It's basically a cloud-based kind of like registry. So Docker Hub is kind of is a registry. So anybody, well, a lot of cloud services actually have their own registry. So it's not necessary you have to host it on Docker Hub. Docker Hub is just like one of the popular ones. So Azure's got their own one. I think it's called ACR, Azure Container Registry. So you can push it up to Azure Container Registry. Google's got their own one. I think depending on, I guess, how your production environment kind of works, in my opinion, if you're moving towards cloud, you probably want to stick your images closer to the cloud places. So if you're going fully Azure, you probably want to move your doc images or use the registry from Azure more, because it'll be on the same network. It'll basically be a bit quicker than having to go out to Docker Hub and then put it to the cloud. Because the Azure container history is on the same network for the Azure stuff, it'll be a lot quicker that way.
Right.
But I guess for us, because we don't know, we haven't really I guess we are potentially moving towards Google Cloud, but I guess because we're kind of like all over the place, where we've got some stuff on-prem, we've got stuff in Azure, and we've got stuff potentially will go in Google Cloud, or it's a lot simpler for us to be in the Docker Hub because it's in one place. But hopefully over time, if we do switch to Google Cloud, I'll definitely probably recommend us moving towards using the Google Cloud registry.
Yeah. And when you were talking about the Docker jargon and listing them, one of them was engine, and I think you just said it's a bit of software or something.
So
what's an example like of an engine?
So the Docker engine is pretty much the runtime environment. So basically, think of it as like it's the runtime environment. That's what the engine is really. When someone talks about the engine, it's the runtime environment that kind of hosts it. So there's loads of different types. Like Docker's one of many. So Docker is the popular one. There's another one that's popular called Rocket. There's another Docker runtime engine. Well, not Docker, but a container engine.
Yeah, great. Cheers.
Are they interchangeable then, Steve? Can you create a container on Docker and run it on Rocket?
I think potentially you can, because like Rocket's just a runtime. So Docker is kind of like, I guess, the full package. From what I remember, I think you can use Docker to build the image, and then Rocket can run it, because I think a lot of stuff happened in the container area where they used I think there's a container runtime interface now where a lot of them kind of use the same kind of instruction. I guess there's an interface that they kind of use. So from what I think anyway, I could be wrong, but I'm sure if you do build it with Docker stuff, it should be able to run on Rocket.
Cool. I got another one for you, Steve.
Yeah.
What does the expose thing do in the Docker file? I've never actually understood what it does.
It just exposed that container. So I mean, that port. So if I don't expose that port, if I try it, I think from what I remember, it doesn't expose that port on it. It basically seals it inside the container.
Is that not interchangeable with the -p command? Is it kind of like one or the other?
The -p is different, because the -p one, your host mapping to the container port. So think of it as kind of like a firewall thing. So the container itself, if I say I'm specifying this port, if I don't expose that port on the container, if I try exposing it, it'll be blocked on the container side, so it won't be able to talk to the application.
Really, that's weird. I don't think I've ever exposed a port.
Yeah.
Have any problems?
I've always exposed it anyway, but maybe it could be a Docker runtime thing. Maybe it's a default on it. I could be wrong on that.
Yeah, maybe. I've always used port A, so yeah, maybe.
Any other questions, or we're good?